Assalamualaikum and a very good day everyone. We are from group 19 and our topic is metal casting. So first of all, I will introduce my group members. So the first one is Muhammad Badru Zaman, PD 24022, and the next one is Awani Humaira, which is me, PD 24017, and Nur Alisa Husna, PD 24019. Okay, so now our group will present about expandable mode casting, but we only share about sand casting. So, what is sand casting? Let's go dive into a deeper. So, basically, sand casting is a metal casting process that involves creating a mold from a mixture sand and a binding agent, such as clay. In this process, molten metal is poured into the sand mold, where it solidifies to form the desired shape. This method is valued for its flexibility, cost effectiveness, and ability to produce complex shapes, making it suitable for various applications, including engine blocks and cylinder heads.
So I'll continue with applications of sand casting. So sand casting is very common in manufacturing, where manufacturers use it to make many different things like custom parts for car engines, pump pieces, valves, machine bodies, hardware, and tools for the industry. Sand casting is helpful because it can make parts of all sizes from very small size to very large. This help in business of energy, chemical processing, marine defense, construction, and mining. So I will continue with the process of sand casting. So for the first step was pattern making. So pattern making. A pattern is the physical model used to produce the mold cavity. So what is the function of pattern making? So basically, pattern making is for creating the mold cavity, as it is the primary job is to create the correct desired shape of the part inside the sand mold. Next, it is to form internal features, and it can include projections, which is the cores that form hollow sections or internal passages in the final casting. Next, guiding molten metal. Guiding molten metal is for the components like the runner, gates, and risers, which will guide and feed the molten metal and are often part of or designed using the pattern. And then next, reducing defects and costs. A well-made pattern with smooth surfaces helps to reduce defects in the final casting, which ultimately lowers the overall cost of production. Okay, next, there are 5 types of pattern allowance, which the first one is shrinkage allowance. So the problem is the metal gets smaller when it cools down. So how to fix this problem? So the pattern is made bigger than the normal size. So the finished part is the right size after it shrink. Okay, next, draft or taper allowance. So the problem is a straight pattern is hard to pull out of the sand without breaking the mold walls. So how to fix it? So the pattern sides are built with a small slants like cone, so it slides out easily. Next, machining allowance. So the problem is the casting surface is usually rough and we sometimes need very exact size. So the fix is we add extra metal to the pattern so there is enough material to cut off later for a smooth, precise finish. Next, for distortion or camber allowance. So the problem is thin, complicated shapes like U or L shapes can bend when they cool. So the pattern is built intentionally bent the opposite way. So when the metal warps, the finished part ends up straight. And the last one is wrapping allowance. So the problem, the molder must tap the pattern to loosen it before pulling it up. And this tapping makes the mold cavity slightly larger. So we fix it by making the pattern is made slightly smaller to account for the mold cavity getting a little bigger from the tapping. Next, for the second process, which is the core making. So the purpose of the cores is to form an internal cavities and hollow section to create any internal holes passage. So this is to support hollow sections and prevent movement, which there are two major forces. First one is buoyancy force. Sand core is less than the liquid metal, so it will cause metal to push up on the core of sand. And next is metal static pressure. This is the pressure from the weight and flow of molten metal try to shift the sand core. And then this will be positioned using core prints and chaplets. Core prints are added to casting pattern to create seats or recess in sand mold. Chaplets are small metal to support or spaces inside the mold cavity to provide additional support for the core to counteract the upward buoyancy force. For the third process, which is the molding, it is basically made of two parts, which is the first one is cope, the top half, and second one is drag, the bottom part. So basically, this is the overall view of molding structure. So the pouring cup is for top opening, and then the riser is for extra vertical metal reservoirs located near the casting, and then core is the preformed sand shapes placed inside the mold cavity, and then cope is top half of the molding flask, which is the combination, and then parting line is the surface or plane where the two halves of the sand mold separate. And then drag. Drag is the bottom half of the molding flask, and mold is the container that gives the final casting its shape. Flux is to support the molding sand, and then runner is a horizontal channels in the mold, and the last one is downsprue, which is the vertical pipe or channel that connect the runner with the top opening. For the fourth process, it is melting and pouring. So basically, the preparation of molten metal is the required metal or alloy is melted in a furnace, and then the molten metal is poured into the sprue of the mold, which is the opening of the mold, and then it will flows into the cavities shaped by the patterns, and then riser supplies extra molten metal during solidification to prevent shrinkage defects, and then sand casting will cool slowly because the sand acts as an insulator. After the metal solidifies, the mold is opened and then casting is removed using either vibrations or other gentle methods. And then the casting industry are improving automation in sand casting to ensure better quality and higher production rate. This is the four types of furnace, which is the first crucible furnace, second cupola, third reverberatory furnace, and the last one is induction furnace that used to melt the metal. And then the fifth process, which is cleaning. Cleaning and polishing are the final step in sand casting, which the runners, the gating system, and leftover mold materials are removed from the casting. So the surface of the casting is ground and polished to achieve the required finish, and then the rough part is shaped into its final or ideal form.
Hi and Assalamualaikum. My name is Muhammad Badrul Zaman, and for my presentation, I will talk about disadvantage and advantage for sand casting. So the first of advantage for sand casting is lower cost of manufacture. Sand casting is not like other method. It's very cheaper and often more viable for most everyday product manufacturers. This is what makes sand casting more cheap other than the other method. So the machine models last for several dozen cycles, making them perfect for pattern needed for extensive production runs. Of advantage for sand casting is it saves lots of time. So while the other methods, sand casting is comparatively fast, but however, manufacturers must think about how much more time will be needed to machine the item. Sand casting produces a rough, product compared to various other methods. So time will be required to refine the final product after it have been removed from the molding sand. So for the last advantage for sand casting is high versatile. The method can help produce product of varying weight and size. The only limit to what can be produced is the shape and size of mold used. However, because it's fast and expensive, sand casting continues to be a method of choice in many industries. It can produce product faster, making it viable option for limited loans, but some machine is needed if the size and shapes tolerance are to be adhered to or to ensure a final finished product. So now I will continue for disadvantage of sand casting. For the first of disadvantage is rough surface finish. So sand casting often leave a rough surface due to sand mold texture. So sand casting require extra finishing like machining or painting, which adds time, cost, or may affect part acquiring, especially in product where SPS matters. So for second of disadvantage is lower dimensional accuracy. So it generally offers less precision than methods. More inconsistencies such as moisture or compaction can cause dimensional deviation. Even we carefully design, tight tolerance are hard to achieve, especially for complex or large parts. In an industries like automotive, often need extra machining, added time cost, and complexity. So the last of disadvantage of sand casting is higher likelihood of defects. So sand casting is prone to defects like shrinkage, gas porosity, and sand occlusion, often caused by poor mold design or inconsistent casting parameters. These flaws can compromise part quality and require strict quality control, especially in industry like aerospace, where safety is critical. Without proper inspection and corrective measure, defects can lead to higher cost and reduced reliability.
So now we will discuss about major casting defects that might occur in sand casting. So the first one is a gas defect, which is blowholes or pinholes. So gas defects occurs when gases like hydrogen, nitrogen, or oxygen trapped in molten metal or mold gases. It will leave holes or cavities inside or on top the surface. So the second one is shrinkage cavities. Shrinkage cavities occur when molten metal solidifies and contract, leading to a reduction in a volume and dimensional changes. It causes by insufficient liquid metal during solidification, improper mold design, and inadequate cooling techniques. Usually, shrinkage cavities found near thick section where the metals cool slowly. So the third one is we have misruns. Misruns occur when the metal fails to completely fill the mold cavity. It causing incomplete shapes. It causes by low pouring temperature, poor metal fluidity, and improper getting design. So the fourth one is we have cold shut. So cold shut, it occurs when two streams of molten metal fail to fuse properly, it resulting in visible seams or weak point in the final product. It causes by low pouring temperature, improper getting design, and inadequate filling speed. So the fifth one, we have sand inclusion. Sand inclusion, it comes with rough scabby surface. It happens when sand particles or other mold material become trapped inside the molten metal as it solidifies. It causes by high pouring rate, mold erosion, improper design, and sand reclamation issues. So next, We have metal penetration. It occurs when molten metal flows into the gaps between the sand grain on the mold surface. It causes the casting surface becomes very rough, uneven and covered with sand particles fused to the material. So next we have mold shift. Mold shift it occurs when misalignment between the cup and drake part of the mold and producing a shifted offset casting. It causes by poor mold preparation, high sand temperature, or excessive mold hardness. So the last one for major casting defects, we have swell. Swell it occurs when expansion of the casting surface due to gas temperature or mold distortion. It causes by insufficient riser design, improper cooling rates, or inadequate metal feeding.
And then lastly, for the conclusions, so basically sand and casting is one of the oldest and most widely used metal casting process in human history. It remains popular because it is versatile, affordable, and capable of producing components in many different sizes, shapes, and levels of complexity. The sand used for most is inexpensive and highly refractory, making it suitable even for casting high temperature metals like steel. Due to its flexibility and relatively low tooling costs, sand casting is particularly effective for low to medium production volumes. It is also commonly used to produce both one-piece castings and components intended for welding or further fabrication. That's all from us. Thank you.